Okay, this question has a lot of what I will call fluff. All right, it's not relevant to the math question at all, but sometimes they put it in there for exams, I guess to add a bit of context, but in this case, it is not irrelevant. So the only bit of the actual question is this purple bit here. All right, but if you're interested in first year uni at UWA for engineering, they got us to make these water bottle rockets and shoot them across, pump them up with water, and I guess it would shoot a certain distance. And top marks to those who could accurately predict where it would go. But back to the math question. For us, this is calculator assumed, so we will need to use a calculator. Now, what we want to do is we want to find the area under the curve. Okay, the area under the curve for a really simple thing like this particular function here for y is equal to x, all right? And if we want to say that it starts at 0 and finishes at 2, and if we plot this thing, the area under the curve is this area here. Now you can probably figure that out because it's just half base times height, sort of triangle. So the area in the really simple case is going to be equal to 2 times by 2 times by a half. All right, the answer is 2 units squared. Okay, but, we can do it a math way, and that is by integrating it from a lower bound. So the lower bound, which we know is 0 in our little sub-example and goes to 2, and we integrate that equation. So when we integrate things, it's the opposite of differentiating. So what we do is we first of all plus 1 to the top there, and then divide by 2. So 1 plus 1. Okay, so now that we know that, we can say that our definite integral is equal to this so far, with a 2 and a 0. Okay, so then what we can do is then plug in the values. So it'll be 2 squared minus 0. So in this case here, it would be 2 units squared. Okay, so really simple example, but hopefully that explains basic integration. If you don't know that, definitely read up on some of the other questions in this website, and that'll help explain it. But for our one, we need to know what this thing looks like, all right? Because it starts at 0, but it does something and then crosses the axis intersection. So it does something and then kind of goes here, and we want to find that area. Okay, so it's all calculator from here, really. This whole question is calculator, but so I guess we need to understand how to use a calculator. So good thing I've got a calculator working here. So what we can do is go to main or menu, and we want to go to graph and tab here. So we will need to punch in our values. So in math, it's a minus sign, and it is e to the power of x squared. What was it? I do have it in clipboard. Minus 2x minus 2x minus 3, and that's all divided by 600. All right. All right, so we hit this one to say that we're going to plot it, and then we hit that one there, and it plots it. So I do have it set up like quite nicely, but if you hit this one, so you can see where I've hit that, and go default, that will set it up how we need to. Now, we're going to modify this so you can zoom in onto the right area, but we know that our x value has to be 0. All right, it's still kind of not zoomed in as, so we can zoom in, I guess, but it kind of disrupts everything. So put a 0 there. We know that it's potentially positive, and if we apply that, we get it that it's positive there. So we want to make our x, I guess, value. We want to make that 0, and maybe like something like 0.5. All right, so now we're starting to see something. So really quickly, now that we know what this thing looks like, all right, we can plot it. So there we go. It'll look like something like this. So if we want to figure out where the intersect happens, we can go analysis, gsolve, and root. And so there's some root y is equal to 0, but if we go across, it might not be visible there. We might just need to zoom out just a little bit. Zoom out. And again, analysis, gsolve, root. So we've got one at -1, but we can't be that because, our 0, it has to be from the question 0 or greater. But we can go to the next one at 3. So you see that 3 and then comma 0. So we know now where this thing intersects. All right. And now we can, I guess, get to our equation and write this, uh, solve it with an integral. So what we can do is go to main. You can also solve it in this way and pick 3 there. But if we paste this down and we select this interactive calculation, we're going to integrate this. It's going to be a definite integral. Now our lower bound is going to be 0, and we've just solved for it being 3. Okay. Now this will give us our area. What sometimes happens is we get a negative value. An area always has to be positive. Okay, so to ensure that it's always positive, we can wrap everything in our equation here in absolute values with this one. And this always makes it positive. Even if I get rid of that negative sign, so it will produce the wrong number there, it will still give us a positive. So that kind of helps you plot the area. So if it's area, always wrap it in that absolute value. So that's in math 1, and it will always give you that positive value. Cool. So then that's how you copy and paste it in, and that is, I guess, your answers. So when it comes to here, there's a few steps that you need to do. First step is to say, so gsolve. So x-intercept values were -1 and 3, but you have to let the marker know, all right, that xn must be greater than or equal, or really just greater than 0, okay? So then what we have to do is explain how we're doing it. We're going to integrate this thing from 0 to 3, and we write it all out. Okay. And it was a -3, all divided by 600. Okay. And then dx, and we can put in the absolute values to indicate that this is equal to area. All right, and then finally, what we have to do is say that area is now equal to our value of 0.0668 6 units squared. So you have to put units squared in. In this case, it is meters squared because we're giving context to the question, but that's how you answer it.